Hello learners, welcome back. In this video we will review lines, slopes, as well as parallel and perpendicular lines. Recall that the standard equation of a line is written as ax plus by equals c, where a and b are both not equal to 0. Now, consider this equation. 2x minus y equals 1. Again, using table of values we can generate ordered pairs which are points on the plane. And since the given equation follows the standard equation of a line, connecting these points will give us a straight line. Let us compare horizontal and vertical lines on the 2D plane. Generally, horizontal line has the form y equals k for some real number k. This is true for any real number x. And thus, we have a horizontal line. For vertical lines, we could have x equals h for some real number h. This is true for any real number y. Y is the same all throughout, so we have a vertical line. Don't forget the fact that 2 points determine a line. We define the slope of a line to be the degree of steepness of the line. The slope of the line passing through points x1, y1 and x2, y2 is given by m. This is always defined when x1 is not equal to x2. And remember, interchanging the indices of the variables doesn't affect the value of m. Take note of these remarks. First, vertical lines have undefined slope. This means that the points on the line have the same x-coordinates. Second, lines with zero slope are always horizontal. This means that the points on the line have the same y-coordinates. Let us look at the behavior of lines in the 2D plane with respect to their slopes. Lines with positive slope are increasing from left to right. Consider x2 greater than x1 and y2 greater than y1. Then using the slope formula we have this greater than 0 or positive. So this should the line look like in the Cartesian plane. On the other hand, lines with negative slope are decreasing from left to right. Here, we also let x2 greater than x1. But this time, y2 less than y1. Then using again the slope formula, we have this less than 0 or negative. So this is what a negative sloping line looks like in the Cartesian plane. For example, let us find the slope of the line through 2, 3, and 4, negative 1. We just apply the formula for slope and we get negative 1/2. We can also get the same answer when we try to swap your xi and yi. Okay. Let us consider line L. X plus 4y equals 13. Note that points, negative 3, 4, and 5, 2, are contained in L. So using the slope formula, we have negative 1/4. Remember that given a point P and a real number r, there exists a unique line through P with slope m. Consider a line that passes through P with slope m. Let xy be a point on the line. Xy satisfies the equation which in fact comes from the formula of slope. This is called the point-slope form of the equation of line passing through P with slope m. Take note also that the general form of a line is the one with a zero right-hand side. Let us revisit our previous example earlier. Find an equation of the line that passes through negative 3, 4, and 5, 2. Getting the slope of the line, we have negative 1/4. Using the point P, the line has now the equation. In standard form, we have. Then we arrive at this final answer which is x plus 4y equals 13. Now, an alternative solution is to use point Q instead of point P. Still, we arrive at the same answer. Let us now summarize the different forms of equation of a line. We have the standard form. Ax plus by equals c with a and b not both 0. We have general form. Ax plus by plus c equals 0 with a and b not both 0. Also, we have the point-slope form. Y minus y0 equals m times the quantity, x minus x0. Here, m is the slope of the line which contains point P. Then we have the slope-intercept form which is y equals mx plus b, with slope m and y-intercept b. The two-point formula then follows from this form. Consider a vertical line. Because the slope of a vertical line is undefined, we cannot apply the point-slope form. Just for a simple illustration, let's have x plus 4y equals 13. By simple manipulation, we can always express this in point-slope form. Sounds easy, right? You might have heard parallel lines several times already. What comes to your mind when you hear the word parallel with respect to lines? Yes, they are lines that do not meet each other. But aside from that, parallel lines have something to do with their steepness on the Cartesian plane. Consider the following definitions. Two distinct lines L1 and L2 are said to be parallel if their slopes are equal. That is, M1 is equal to M2. In symbols, we write this to say L1 and L2 are parallel. Consider a line L with an equation y equals 2x plus 3. Suppose we are interested with another line passing at point 1, 1, parallel to L. Again, the easiest way to graph this line is to find the intercepts. So this is now point P. And the red line is the line parallel to L. Remember that points are said to be collinear if they are lying on the same line. And you need at least 3 lines to impose collinearity. But in this case, we only need 2 points to draw a line. Going back to the equation L, we get slope equal to 2. Hence, the line through P with this slope has the equation y equals 2x minus 1. That's it. Take a look at again the sketch in the Cartesian plane. Let's now have perpendicular lines. Two distinct lines L1 and L2 are said to be perpendicular if the product of their slopes is -1. In symbols, we write this to say L1 and L2 are perpendicular. It is also correct to say that slopes of perpendicular lines are negative reciprocal of one another. Consider again the same illustration. So we have line L, a point P outside of L. And there's a line, perpendicular to L, passing at P. Since the slope of L is 2, then it follows that the slope of the line perpendicular to it is -1/2. Hence, the line through P with this slope has the equation y equals -1/2 x plus 3/2. So we're done. Take a look at again the sketch in the Cartesian plane. Try this bonus question. Let us know if you can answer this and leave us a comment below for your answers. In our next video, we'll talk about circles in the 2D plane. Thank you for watching. See you in the next video.